Okay, y'all, we are going to find the derivative of this quadratic function using the four-step process. That means we need to find the limit of the difference quotient as h goes to 0. Step 1 is going to be to figure out what expression we get when we input x plus h into this function rule. And I'm going to do that with some side work. Okay, here is the side work. What did I do? I found f of x plus h. So our function rule says if you input x, you're going to do the input squared and then multiply that by 3. So here our input is just going to be the expression x plus h. We're inputting a binomial into the function. So I'm going to do the input squared. That means I'm going to do x plus h squared, and then I'll multiply the result by 3. So if we're going to do that binomial input squared, I need to write the binomial out twice. And then you either distribute that or FOIL that or whatever you learn to do to multiply two binomials, and you're going to get this expression. I can go ahead and simplify that expression because there are some like terms. I end up with an x plus h term, and I'm adding an h plus x term. Well, order doesn't matter when we multiply. So I can rewrite that h times x as a x times h. So I have two of those terms. They add together. I get 2xh. And then I just need to multiply that whole expression by 3. So I'm going to distribute 3 to all 3 terms in that resulting trinomial. And when I do that, I end up getting this expression. So wherever I see f of x plus h, I can replace it with this expression. And that's what I'm going to do up here. Okay, so I rewrote my limit of the difference quotient, but I just replaced the f of x plus h with that expression I got in my side work. Now I need to subtract f of x. F of x is my original function rule that I'm given. So instead of subtracting f of x, I'm going to subtract that original function rule, which was just 3x squared. And I put it in brackets here. I could have also used parentheses, but the original function rule is a monomial, so I don't have to be super careful. When I go to subtract that original function rule, there's just one term, so I don't have to worry about distributing the subtraction. So let's go ahead and do that and clean up this limit. Okay, so my next step, I just subtracted the 3x squared as part of my expression. And I can simplify this numerator because I had a 3x squared at the beginning of the numerator, and now I'm subtracting 3x squared. So those are going to combine to 0. So I'm just going to be left with this 6xh plus 3h squared in my numerator. And then I can simplify that. So I'm going to simplify that by factoring an h out of that numerator. And then the h factor in the numerator will divide out with the h in the denominator. These divide to 1. So I'm really just finding the limit of that remaining binomial of 6x plus 3h. Now I can plug in 0 for h, right? My input is approaching 0, so we have a theorem that says you can just plug in h equals 0. So wherever I see an h in my expression that I'm taking the limit of, right there, I'm going to plug in a 0. So I really have 6x plus 3 times 0, which is just 6x plus 0, which is just 6x. So my derivative of this original function is just 6x. So what is that telling me? Well, the original function up here, this f of x, this is calculating the points on the graph of f. Okay. The derivative is calculating the slope of the tangent line for that input x. Okay, so let's just verify that this derivative rule I found makes sense. I'm going to graph my original function. It's a parabola, it opens up, and I'm just going to plug in different inputs and see if the derivative we calculate makes sense to describe the slope of the tangent line at that point. So let's do it. Okay, so let's test out some different inputs. let's see what happens when we input a -1 into the original function and we input the same number into the derivative. So -1 is here on my graph. I can come up and see that hits this point right there. That hits the point -1, 3 on this parabola. That's the graph of our function. So if I plug x equals -1 into the original function, if I input -1 into that function, I can see that I calculate the point -1, 3, because the original function calculates points on the graph. Well, the derivative, if I plug -1 into that derivative, it's going to calculate the slope of the tangent line at that point. So that's what I've done here. I plugged -1 into the derivative rule, which says 6 times x. So 6 times the input, that's 6 times -1. That gave me a slope of -6. Does that make sense? I don't know. Let's draw the tangent line here. I'm going to draw a tangent line at this point, -1, 3. Tangent line would look something like that. I mean, I don't know exactly if the slope is -6, but it makes sense that it's a negative slope because it's pointing down. So, I mean, it makes sense. It could be feasible. Let's try another input to see if this is making sense. This one might be a little more clear. X equals 0. That input right there, that's this ordered pair. I can see just from my knowledge of algebra that the tangent line there is horizontal. I know the slope of a horizontal line. The slope of a horizontal line is 0. So if I plug in x equals 0 into the derivative, I better get 0 out because I can see the tangent line is horizontal. I know the slope of a tangent line that's horizontal will be 0. So let's try it. Let's plug in x equals 0. Now again, if I plug it into my function, the function rule said 3 inputs squared. Well, 3 times 0 squared is 0. I see that ordered pair in my graph, 0, 0. But what if I plug it into my derivative rule? My derivative rule said 6 times the input. Well, 6 times 0 is still 0, so I have a slope of 0, the tangent line right there. This tangent line, slope of 0, it's horizontal. And let's do another one. Let's test the point x equals 1. Okay, x equals 1 is right here. If I come up to my graph, I can see that happens at the point 1, 3. I can get that information if I plug in x equals 1 into the original function. So let's do that. Remember, the original function rule said 3 times input squared, and I'm putting a 1 in there. Well, 3 times 1 squared is 3. So see how I got that ordered pair? When x was a 1, the output was a 3. Okay, now if I plug that input into the derivative rule says 6 times the input. I'm plugging in a 1. That's a slope of 6. Would it make sense, I'm going to draw my tangent line, would it make sense for the slope to be a positive 6? I mean, I don't know if it's exactly equal to 6, but I can definitely see I have a positive sloping tangent line. It's pointing up there. And it does also make sense, if I'm thinking about it, that this parabola, this U-shaped graph, is symmetric. And I picked 2 symmetrical points on my graph around that axis of symmetry. So if the slope of -1, 3 was -6, then that symmetrical point on the other side would make sense to have the opposite slope, which would be positive 6. So it's making sense. So this derivative rule is calculating the slope of the line, of the tangent line, on each point of that graph. This takes a lot of practice, y'all. So reach out to other human beings if you're getting stuck. Reach out to me, reach out to the embedded tutor, to our instructional associates, to your classmates, to the Learning Lab tutors. You cannot learn this in isolation, y'all. You need to talk it out. Okay, good luck.